Today we begin on page 10 of our Chapter 4 notes packet. Section 410, Inverse Variation. Recall previously from earlier in the chapter, direct variation. Two quantities vary directly if their ratio or quotient is a constant. Y divided by x is equal to some constant k. Can also be written as y equals k times x, right? If we simply multiply both sides by x, we have y equals k times x. So direct variation, think of divide. Example, y varies directly as x. I would stop right there and say, if y varies directly as x, then y divided by x equals some constant k. And y equals 48 when x equals 4. So in this case, replace y with 48, x with 4. What is 48 divided by 4? It is 12, so our constant would be 12. So k equals 12. Find x when y is 36. So y divided by x, 36 divided by x, would have to come out to equal our constant that we found for this particular example, which is 12. And if we simply multiply both sides by x, we have 36 equals 12x, and divide by 12, x equals 3. Recall that the graph of a direct variation is a line that passes through the origin. The graph of a direct variation is always going to be a straight line that passes through the origin. Okay, so that was from earlier in the chapter. Now, this section, inverse variation. Two quantities vary inversely if their product is a constant. So x times y equals a constant k. For example, if x varies inversely as y, let's stop right there. As soon as you see these words, that means their product, x times y, is going to equal some constant k. Now, if x equals 12 when y equals 8, all right, so we replace x with 12 and y with 8. What is 12 times 8? Well, 12 times 8 is 96. So our constant for this particular problem or example is 96. Find x when y is equal to 10. So x times 10 has to equal our constant of 96. If I divide by 10 both sides, we have x equals 9.6. That's our value for x. Number 2, if x varies inversely as y, again, varying inversely, x times y equals some constant k. If x equals 9 when y equals 4, 9 times 4 is our value for k, which is 36. Find y when x is equal to 12. So 12 times y is equal to 36. Divide by 12 and y equals 3. Now the bottom third here, the graphing piece of this on page 10, we'll do together in class tomorrow. So on to page 11, we're going to work out a few selected problems here, starting with problem number 1. More examples or practice of inverse variation. If x varies inversely as y, again, as soon as you see those words, you're thinking the product is a constant. So x times y equals some constant k. And x equals 12 when y equals 3. Multiply those two, right? Just multiply. What is 12 times 3? It's 36. We don't have to show this work each time. So 36 is equal to k. What is the value of x when y equals 9? All right. So x times 9 equals 36. Divide by 9 and x equals 4. So that would be choice option C. Next, number 3. Y varies inversely as x. That means the product here is a constant. What's 18 times 35? I might have to get out the calculator for this. That's 630. So 18 times 35 equals our constant k. That's 630. And what is y when x is 21? Well, 21 times y has to equal 630. So take 630 and divide it by 21. And that is 30. Number 4. Given that y varies inversely as x squared, all right, that means y times x squared is equal to a constant. And y equals 8 when x is 12. 8 times 12 squared equals our constant. We go to the calculator. 8 times 12 squared is 1,152. What is the value of y when x is 6? Y times 6 has to equal our 1,152. Divide 1,152 by 6, and we get 192. Nope, not a choice there. Because what did I fail to do? Right? Y varies inversely as x squared. Forgot to square my 6. So let's take our 1,152 and divide it by x squared. 6 squared is 36, and that's 32. So y times 36 equals 1,152. Dividing both sides by 36, y equals 32. Option C. Number 5. Given that y varies inversely as the square root of x. Right? Varies inversely their product. Y times the square root of x is going to equal the constant k. Y is 8 when x is 12. So 8 times the square root of 12 equals k. Not sure if we want to simplify this yet. Let's see. What is the value of y when x is 6? So y times the square root of 6 has to come out to equal our 8 square root of 12. Divide both sides by square root of 6. Y is equal to square root of 12 divided by square root of 6 is square root of 2. So 8 square root of 2, which is option B. Next one we're going to do is number 7. Which equation shows that P varies inversely as Q? So their product P times Q is going to equal some constant K. Now look at our options. The first one, P times Q equals 10. Option A. And the last one on this page we're going to do together is number 13. Number 13, if A and B vary inversely, and as soon as you see those words, their product, A times B, is equal to a constant. And A equals 8 when B is negative 3. We'll multiply that. 8 times negative 3 is negative 24. Negative 24 equals our constant K. Find A when B is negative 12. So A times negative 12 equals negative 24. Divide by negative 12, and A equals positive 2. So A is 2. I think I'll just leave it here. Circle our answer here. Next, page 11, doing some, on to page 12, some selected problems here. Starting with number 1, tell whether x and y show direct variation, inverse variation, or neither. Okay, so for direct variation, remember divide. That would mean that x divided by y equals some constant k, or it could be y divided by x equals a constant k. For inverse variation, their product is a constant, x times y equals k. So for number 1, well, let's see about getting x and y on the same side of the equation. So if I take y equals 3x and I divide both sides by x, then we have y divided by x equals the constant 3. So this would be an example of direct variation. Because the quotient is a constant. Continuing with the odds, so number 3 next. X plus y equals 7. Well, x and y are already on the same side of the equation. It's not division or multiplication, so this is neither. The next group, the variables x and y vary inversely. Use the given values to write an equation relating x and y, then find y when x is 4. Okay, these vary inversely, so the product is a constant. So our equation would be x times y equals constant k. Plug in our values. 2 times 4 is 8. So our equation would be x times y is equal to 8. This is our equation. The second part, find y when x equals 4. Substitute 4 in for y, and we have x times 4 equals 8. Excuse me, we're substituting 4 in for x. So 4 times y equals 8. Divide by 4, and y equals 2. So 2 parts here, the equation, then finding the value of y. Continuing with the odds, number 7. Again, the product is a constant. In this case, what is the product of negative 4 and 9? It is negative 36. So x times y equals negative 36. This is our equation. xy equals negative 36. Finding y when x is 4. 4 times y equals negative 36. Divide by 4. Y equals negative 9. Number 9. Again, still varying inversely. X times y equals our constant k. 16 times a quarter is 4. So our constant k is 4. Our equation, xy equals 4. Find y when x is 4. Well, 4 times y equals 4, so y equals 1. And 11 through 14 says determine whether x and y show direct variation, inverse variation, or neither. Okay, so we're just simply going to try. First, if I try for direct, is there a constant ratio here? So if I take y divided by x, 12 divided by 3 equals 4. Is 32 divided by 8 the same? That is 4, and 44 divided by 11 is 4, and 2 divided by a half, or 0.5, is 4. So this would be an example of direct variation. If the quotient comes out to be the same constant. And 13, I'll try the same. I'll first try dividing. 1 divided by 3 is simply 1/3. Is 0.5 divided by 6 the same? Use the calculator if need be. 0.5 divided by 6 is 0.083 repeating, and 1/3 is equivalent to 0.3 repeating, so that No. Abandon the direct variation. Now let's try to see if it varies inversely. So is the product a constant? I'll do this on the other side. So I'm taking 3 times 1 is equal to 3. Is 6 times 0.05 the same? 6 times 0.05 is 3. 10 times 0.3, yes, that's 3. And 12 times a quarter is 3. So the product is the constant 3. So we have, this is a inverse variation. Okay, and this concludes our video for tonight.